Okay, hi guys. So I'm going to show you how to use Excel and generating equations in Excel in order to calculate your percent survival and percent mutation better for the Yeast UV mini report that's due at the beginning of class Tuesday morning on Canvas. So first let's do percent survival. I've pasted the equation here. So the equation for percent survival relative to control is equal to number of colonies on the plate divided by number of colonies on the 0-second plate times 100. So percent survival, we're using the SC plate data, and we use the SC plate because that's a synthetic complete, and that is acting as our positive control because with the synthetic complete, our TRIP 1289 mutants, which can't make tryptophan, have the tryptophan present in the media, so they should be acting as wild type yeast. So that's what I have pasted here. This is just the SC plate data. So you have time of UV irradiation in seconds, and then individual. These numbers I just made up because I personally didn't have a group, but you guys, this is where your group numbers come in. Section 1105, that's our section number. These are the averages from the class. And then L113 column, this is the averages from all the sections of L113. So the way that you can create equations in Excel is I click this box here, you can see the equation that I've already generated up here. And so the way that you make a new one, for example, I'll just do it down here so you can see what it looks like. Actually, let me undo that because I just accidentally edited it. But if I click down here and I press the equal sign, now once you press the equal sign, then it starts generating an equation. And so that's how you start it. But I will just backspace that and go back up to the equation I've already made. So you see I have selected B2. So if I click on that, it'll highlight where it is. So that B2 is the number of colonies on the plate divided by number of colonies on the 0-second plate, which since this is a 0-second plate, is just divided by 740 times 100. And then once you've generated that equation, if you click on the box again, the cell that you selected is highlighted in green, and in the bottom right of that, there's like a little filled in green square. If you get close, then your pointer turns into a crosshairs and you can click and pull down. And once I pull down and let go, now what it does is it moves that, if you look up here in the equation, so now see how the first one is B2, if you go down to the second one, now it's B3. So it's progressing down your data set and it's automatically doing it for all the other ones. So you can see as UV irradiation progresses, your percent survival decreases, which is what you would expect. And you can also, if I delete these here, you can also click on the box and highlight it and drag that green square to the right. Oh, actually that didn't work, never mind. Let me go back. So then for the section and for the L113 data, you just have to fill out this equation also in that way. And once you fill it out and you drag it down, you will have your percent mutations. And then what you can do is you just highlight all of this, go to Insert, and then you want to use the Scatter XY, or it might be called the bubble chart, and click on the dots, and this will give you your graph. And when it gives it to you, it's pretty much blank. You have to enter a title, you have to add axes. So if you click anywhere on the graph, if you click, you'll get this these three options that pop up. If you click the plus, there's an option for axis titles. If you click that, they'll show up, and then you can double click on them to change the name. And I'm going to delete this graph because I have one over here to the right that's already complete. So this is be an example of a title and your axes names. And let me show you here actually. If I click on the data points, it'll pull up this format data series option here on the right. If you go to the like the pouring paint icon, right now I've selected solid line. The default is no line, so you need to add a line in, and then you can see there it gets generated in, and you want to change the color to match the data point of the dot. Okay, so that's percent survival. Let's go to percent mutation. It's essentially the same thing, but this one's a little more complicated because you're using SD plate data as well as SC plate data. And so these I've just copied and pasted from the other tabs. This is the SD data up here, and then down here is the SC data. And then again, with the equation up here, this is the one that I've generated. And you want to be careful with the parentheses to make sure that they're blocked in correctly, otherwise your order of operations is going to get messed up. So if you click on it, you can see the percent mutation equation is number of colonies on SD plate, which I have selected up here, so that's 5, divided by number of colonies on SC plate, which is down here, 740, times 10,000, and the reason we multiply by 10,000 is because we did the 10 to the minus 4 dilution, so we want to bring it back to the same amount, and then times 100 to get the percentage. And then once you enter that equation, you get this really small number. And so I'm pretty sure the default in Excel is scientific notation, so let's just drag that box down so you get all of your scientific notations. And the E just indicates it times 10, so the way you read this is 6.76 times 10 to the minus 0.5. If you don't like scientific notation, if you highlight them, you can go up to this box here under the Home tab and then change it to number. And right now they all show 0 because these numbers are really small. So you can move these, increase or decrease the decimal. So if you increase it, then you can see all those numbers again. Okay, so I'll leave that one in number format. And then here, this is for the section average data. You can see that now instead of group, we're in the section data. And down here, and then I'll drag this box down to fill out those. And then the same thing for the L113. I'll fill out those. Now, if we go over to my the graph that I had pre-created, I've changed these. I've changed the group column into number instead of scientific notation, so now this axis is in number format. I don't care if you do number format with decimals or scientific notation. Just make sure that you have enough decimals so that I can see the numbers and it doesn't just say 0.00. These ones I have not added lines to though, so if you click on one of the data series, if you click on one of the dots and you go to the paint icon and click no line, you click solid line. This one filled for L113, which is gray, so that matches. And do the blue next, solid line. The line's still gray, so I'm going to change it to blue. And then do orange last, and solid line, make that orange. Okay, that's what that should look like. And also on the bottom, this is our UV irradiation in seconds, that should say. And because the maximum value we did for UV irradiation was 120, I'm going to click, I just clicked right here near the 120 and it highlighted the axes. And then if you go to, which one was it? You go to this 3-bar icon and click axis options, you can change your maximum right here. So I'm going to change that to 120. And that just moved the graph over a little bit, so it just maximized the space that was being used. And in your title, make sure you capitalize the TRIP1289 because that's referring to the gene, and you should be good. Let me know if you have any questions. I'm more than happy to help. I'll see you on Tuesday.